So good morning, NDC, and thank you all for coming to my little talk at 9 a.m. after the party. That's a big vote of confidence. I thank you. So I can see that we are ready to start. So this is a little talk that I've named How Hacking Works, and this is the web edition. I had another one at NDC Security, which was a much broader one. I went into more different kinds of subjects. But today we're only going to focus on the web and web applications and web vulnerabilities. But before we get started, let's do the obligatory who am I, so you get to know me a little bit. So my name is Espen Sande-Larsen. I worked as a developer for the better part of 25 years, and I've had several roles over the years. I've been a developer, a tech lead, architect, even a hacker. But you may also not know that I am a musician. I release music. You can listen to me on Spotify or not. Hashtag shameless plug. And I'm the father of 3. And I really love to do tech stuff, not just for work, for my hobbies as well. So my hobbies are kind of like everything computer related. But I also like flying drones. So when I'm not tinkering with hardware and software and stuff like that, I really enjoy drinking beer and having fun and doing all sorts of mischievous stuff. And my job is I work at DNB Bank. It's this little bank in the Nordics. And I work in a division called the New Tech Lab. And New Tech Lab is this kind of R&D division that gets to play with new technologies and cutting edge stuff. So I get to play with all the latest and greatest and newest toys and build like projects and code up experiments and stuff like that. And part of that is security and doing security research. And currently working on quantum computing and breaking encryption using quantum computers, which is kind of fun. And before we proceed, I have to do this obligatory one as well. This is a disclaimer. This is legalese saying that everything you're about to hear that I'm saying is me saying and not necessarily DNB saying. So with that said, that's out of the way. I got started out in computing back in what I like to refer to as the golden days. I started out with this magical machine. Some of you may have seen it, some of you may have played with it. Some of you may think, what the hell is that thing? It's the Commodore 64, and it was this amazing machine that my brother bought home. He had traded a piece of illicit substance for this computer, and ever since that day I got hooked on computers and not drugs. And it was amazing trying to get that thing to work. I remember the first time we got it because we didn't get a manual or anything or a game. So all you had was an operating system, which basically was a programming language. And in order to get it to do stuff, you had to program it. And we didn't have like JavaScript or high-level stuff back then. You had to really know that machine and figure out how it worked. You had to figure out the memory model and the instruction sets and stuff like that in order to get it to do stuff. Which is why I feel that I may have a little bit of an advantage when it comes to the security-related stuff, because that taught me to be curious and poke at things and try to figure out how stuff really works under the hood. But in order to discuss what hacking is and how it works, we need to know exactly what is hacking. What do we mean when we talk about hacking? And what better to do than consult Hollywood and movies and TV, because they clearly have a good understanding, right? So this is from a TV show called NCIS. There's a hack in progress, and they have to defend against it, and that's how it looks like.
No way.
There's no sound.
I'm getting hacked. Of course. No, this is major.
Yeah, so they're getting hacked, and the way you know you're getting hacked is you get a million pop-ups. And the way you defend against an attack is you get on a keyboard, you just bash out the keys, and what's better than one defender than with 2 defenders on the same keyboard, because that's how keyboards work. And computers, evidently. And of course, in order to save the day, it's not the professionals, it's the non-technical person who just strolls casually into the room. Oh, we're getting hacked, awesome. One with a sandwich. And this non-technical person solves the entire thing by doing this.
Where'd he go? I didn't do anything, I thought you did.
No. I did.
So he just unplugged the computer, because that's how you stop an attack. Because in this entire government organization, all the essential files and documents and things the attackers wanted to access was on that one single terminal. That's how it works. Is it possible to get more sound on the videos, please? Yeah. Because the next one is really important that you listen well. Because This is a TV show about forensic specialists and analysts, and this is CSI. And just listen to this gem. They evidently did their research, right?
For weeks, I've been investigating the cabbie killer murders with a certain morbid fascination.
This is in real time.
I'll create a GUI interface using Visual Basic. See if I can track an IP address.
I'll create a GUI interface using Visual Basic and see if I can find an IP address. I don't even know how to comment on that. Evidently, they didn't even bother, okay? So yeah. And what about a movie that's named Hackers? They probably get it right, right? They have to do research. Just look at that keyboard. So there's a virus, and the virus eats memory, like Pac-Man.
Replicating, eating up memory. What do I do?
Type cookie, you idiot.
And you just type cookie to get it away. And of course, the defender has to go into this 3D environment and shoot down the attackers using lasers. Look at this. Yeah. Take that, you hackers. And of course, you have this circular keyboard.
A rabbit is in the administration system.
Send a flu shot.
That sounds bad.
Flu shot, someone talk to me.
A rabbit replicates till it overloads a file, then it spreads like cancer.
Cancer?
Yeah, no, that's not a thing. And these keyboards aren't a thing either. How about a show that's about a hacker? That's the entire plot of the show. They probably did some research, right? So in this scene, there's malware on a plane, and they have to figure out how to patch that plane. And the only way to do so is the programmer has to get, or the hacker has to go in his Ferrari, catch up to the plane, in mid-flight, over the runway. And the poor person from the flight crew has to climb down on the landing gear because the only way to patch the plane is to plug in an Ethernet cable into a laptop. So there's, yeah. So this is my favorite nonsensical example of anything. So, of course, they're running off the runway. So what you do, you have to stretch. So the plane has to gain altitude because it has to clear the tower. And they're running out of cable. So yeah, that's how hacking works. Yeah. Also, that's all nonsense, of course. But let's define what hacking really is, because it used to mean something different back in the day. It used to mean people who were tinkering with software and hardware, and they kind of used components outside of the scope of what they were intended to do. One such example, that's one of my favorites, is Steve Wozniak, who built the color output for the Apple II. And he designed that by just modifying the video signal a little bit. And that will cause the ray cannon inside the screen to misalign, and that caused colors to be able to appear on the screen. So by doing so with the circuitry, he was able to build a computer with a color interface without having a video chip, which is pretty cool. And that was what they used to refer to as hackers. So they had to think outside the box, and they had to figure out how stuff works. But what we refer to as hacking today was originally called phreaking, and that's because it comes from the word phone and freak. And because back then, in order to communicate with computers, you had to call them up on the phone, because we used the phone lines for communications back then. And if you were good at exploiting vulnerabilities, you were a freak, and you did it over the phone, so phreaking was the thing. But now we call that hacking because we kind of evolved away from phone lines and phone systems. But essentially what we're talking about in the scope of this talk and this session today, it's exploiting systems through their vulnerabilities. And this is where I usually do an audience poll, because this talk can take a couple of different turns depending on the audience. But I can't see any of you because of these big lights, so I guess instead of raising hands, you make a sound. So just say, if you agree with the statement, or something like that. So just, how many of you are programmers, coders, you write code for a living? Awesome! That sounded like a chant. Maybe we could get a developer chant going. Anyways, okay, any tech leads, architects, you design the systems, not necessarily code the systems? Yeah, some of those. How about security engineers, pen testers, chief security officers? Hackers? Okay. How about something completely different, like scrum masters or project managers? Okay. Proudly announcing that. Awesome. Cool. Well, that's good. That gives me some ideas for the demo section that's coming up in a bit. In order to define hacker, we also need to define the different kinds of hackers there are, because they have different roles and different motivations. And the way you identify them is you can just look at them in a room and pick out what color hats they are wearing, because they have all these colorful hats on. And that's how you know what sort of hacker you're dealing with. And this comes back from the old Western movies where the good guys had white hats and the bad guys had black hats. So that kind of transcended over to the hacking community. So we have the black hats, that's the malicious people, those who do bad stuff. They do DDoS attacks, or they do phishing campaigns, or do malware and stuff like that. Then we have the white hats. They are the people who are like pen testers, things like that. They do things ethically and they do things with permission. Then we have the in-betweener, that's the gray hat. They do things for good, but not necessarily are always ethical. They may try and exploit somebody without their permission and gambling on that they will get a reward rather than litigation for disclosing what they've found. And then we have what I hope many of you will go out today and be, and that's the green hat hackers. That's the beginner hackers who are starting their journey to learn, which is awesome. They have progressed beyond the script kiddie level. Script kiddies are like people who just find a tool that does some kind of exploit, but they don't know how it works, but they just use it. Then we have the red hat hackers. They are not Linux fans, but they hunt other hackers, take down big hacker organizations, and they kind of do digital warfare. And then we have the last one, that's the blue hat, and they are people who are like hired by companies prior to releasing software to the public, who are invited to try and find exploits. So they, for instance, Microsoft have had a long tradition of having these blue hat events where they invite notable hackers to come in and check out new versions of Windows or Office and big applications like that. And the idea is to find vulnerabilities before things go into the wild and patch them before. So let's discuss, why do hacks happen? Why are people able to exploit systems? And the sad truth is basically because we are developers, we are humans, and we make mistakes. It's not necessarily mistakes that we make on purpose. It can be something that we haven't thought about or overlooked, because software systems are pretty complex and they have many moving parts, and you may not always have the full picture and the full grasp of all the little details that are going on in your system and all the possibilities. And often the devil lies just in those little details. And there's a big thing that's going on that's we've evolved into, and that is we trust other people's code like it's the best thing ever, and it's totally fine. We have all these libraries, all these packages, all these frameworks, and that's essentially other people's code that we are trusting. Sometimes we have millions of lines of other people's codes, and we have like 10 lines of our own code in our system. And trying to have like an overview of all of that is nearly impossible. But the problem is that once you include other people's code in your system, you're also including their vulnerabilities. And also we developers, we tend to fall in love with our tool stacks. It's like if we have a couple of tools we love, we try to use those for everything, even though they may not be intended to that use case. It's kind of like if you're building a house and you need to pour concrete for the foundation, you got a hammer, and you need to mix that cement. You would be better with a cement mixer, but I'll just use my hammer. And I'm going to tell you a story of back when I got hacked, because I really got hacked once at my work. And this cinnamon bun picture is going to make sense in a bit. But what happened was I was hired as a CTO in this startup. And we were going to take over the world. We were going to build this big, giant e-advertising platform that was going to run on all the e-magazines and e-newspapers in Europe and in North America. And the idea was that we will have these like multimedia type ads with games and stuff in them that you can win prizes. So if you play the game, you win a prize, you got a barcode sent to your phone, and you can go to like 7-Eleven and scan that barcode, and you got a prize, like a cup of coffee or something like that. The problem is that when you're the CTO in a tiny startup, you're also the tech lead and the principal architect and also the lead programmer. So I had to build this thing myself as a one-man show. This is back before there were any clouds, there weren't any containers, there weren't any like AWS or serverless things. We had boxes, that's all we had. So I had to set up this distributed real-time system that was going to serve all of Europe. So I had to travel around, set up racks in data centers all over Europe, and get this thing to work together. And then there was this one little detail on top of all this, is because back then, to do what we then called rich content, basically games on websites, there was only one thing you could use, because there weren't any Canvas APIs or graphics APIs in the browsers back then. So you had to use a plugin, and that plugin was Flash. And if you have heard about Flash, you know how awful it is. And if you haven't, well, here's a kickstart course. So this is Flash. It was made by Macromedia. It was intended to make like these interactive presentations that you can burn on a CD and share. And if you notice, it does have a code window, but if you see here, there's a timeline. And you may wonder what that is for, and there's also these drawing tools. And the primary use case for this was to create animations that you can click on. So it was actually made for making cartoons. And it did have a programming interface on top of that that could do like listen to user actions and manipulate state and stuff like that. And it was called ActionScript. It was based on ECMAScript, so it's basically JavaScript. And this all got compiled into this binary format, and you can share that, and it would be played through a plugin in your browser. The problem with this thing is, A, it wasn't intended to be secure. It wasn't intended to do anything that had to do with anything that had value, such as prices and stuff like that. And there was one big thing that I didn't know. I had overlooked this detail because it was compiled, so I thought that's fine. But it turns out it's really easy to reverse engineer. It's easy to decompile. And a Swedish student did just that with my system. And by doing so, he figured out how it worked. He figured out how the game worked. It was this awful game where you had to kill flies and get them off the cinnamon buns. Why you wanted to kill insects and have cinnamon buns at the same time, I don't know, but that was the game. But he managed to find the backend call that we used to generate the prize tickets. And that meant that he could generate as many prize tickets as he wanted. Which was bad. And I got this call early in the morning with my CEO, who was furious at me. Because evidently this person had picked up 73 cinnamon buns in one single day. And that was a big problem. My immediate response was, that person really likes cinnamon buns. She didn't think that was funny, but I thought it was pretty funny. Then I got called in. We had this big meeting, crisis meeting with the board and everyone, and I had to stand there and say, sorry, sir, it's my fault, I'm liable, all that stuff. But I got kind of sick of getting yelled at, so I thought I had to spin this into something positive. So I said, no, we're not going to do this. We're not going to hide this away. What we are going to do, we're going to get a newspaper, and you, the CEO, you're going to go to Sweden, you're going to get a big case of cinnamon buns and find this person and publicly thank him for his service. And they did just that. So the end of the story is in the biggest newspaper in Sweden, the CEO and this hacker with a big case of cinnamon buns and going like this, and this happy news story about how he helped us find vulnerabilities in our system, and we thanked him for it. So that was kind of our bug bounty program, I guess, impromptu. So how can we prevent stuff like this from happening to our applications? Because usually what we do is we build our applications and we get a pen test team going and they test it out and they say everything is okay, we have to fix these things, and then we go live. But after that first pen test, And at your next push of a commit, well, that pen test is basically invalid because you haven't pen tested the new stuff. So one point I'm trying to make with this talk is that if you have those capabilities in your team to kind of like continuously pen test your applications, well, that's beneficial because that makes you, enables you to find more flaws and vulnerabilities easily. And a great way of gaining those skill sets, because it kind of seems like this esoteric thing that may not be approachable and to many people, there is a way to kind of like build this up in an ordered fashion and build those capabilities in your team. And one such mechanism is called CTF. And I want to let Elliot from the incredible show, Mr. Robot, the one show on television that actually gets hacking right, let him explain what it is.
The CTF tournament, capture the flag. It's like the Hacker Olympics. Teams around the world compete to solve challenges, reverse engineering, protocol exploitation, forensics. The entire city's suffering an energy crisis while they're here exercising their inner anarchy.
Yeah, so if it was kind of hard to hear, but he says it's the Hacker Olympics, and you get to exercise your inner anarchy. That's awesome. And he talked about reverse engineering, protocol exploitation, and a couple of different kinds of attacks. And CTFs are just that. They're kind of this organized, gamified way of learning adversarial techniques. You have like these challenges that are designed to encompass one type of vulnerability or one type of attack or one kind of mechanism to try and figure out how hacks happen. And the cool thing about this is they are an incredible catalyst for learning and gaining insights into this kind of mode of thinking. Because it enables you to think differently about stuff. It enables you to think like an attacker. You would start to fuss your inputs and start to be curious and poke and probe at your systems to figure out what would happen if somebody did this. Because we tend to kind of trust our users and think that nobody would ever put this into that field or something like that. But what happens if you do? And that's cool. And you do this by solving these challenges. And we actually have had a couple of CTFs inside of DMB. We had one last fall that we opened up to the entire group, not just like the tech people, but the entire group. And man, did that spark engagement. It was so awesome because suddenly everybody was talking about cybersecurity and hacking and reverse engineering and stuff like that. So we had like these awesome conversations around the coffee machine, cross divisions and cross business areas. And that was pretty fun. And my favorite email that I ever got in DMB was from a lawyer in legal who sent me a letter of apology because he had performed a SQL injection attack on one of the challenges in my CTF. And he had accidentally deleted the entire database, so he wanted to say sorry. And when the lawyers in your legal department are performing SQL injection attacks, well, that's just you're doing something right. That's so awesome. So that's my favorite email. And I must admit, it's so fun just to be able to be the villain or the bad guy for once. And you can do so in a safe environment. So we have these challenges, or chals, as they are referred to. They come in different categories, and those categories are kind of designed to kind of flip your mind into what kind of mode you need and what kind of tools you would need to solve the challenge. And they're also tuned into different kinds of things they are trying to teach you. So we have like crypto, that's not Bitcoin, it's cryptography. So it's all about breaking encryption and breaking codes. It's also about, we'll teach you about weaknesses from different encryption schemes and stuff like that. We have stego, which is steganography, which is basically when you're hiding something inside something else. So you can hide a binary file inside an image and nobody would know it's there. Then we have forensics, where you get to analyze network traffic or file systems and stuff like that, try and find digital clues. We have reverse engineering, and now we're getting into real hacker territory. That's where you have to figure out the program, how it works, and figure out how to exploit it. Then we have vulnerabilities, which is usually third-party vulnerabilities that are probably known, that you have to figure out how they work and how to exploit them. So that's other people's code. And then we have web, which is everything above, but all tuned into some kind of web app. And then we have pawning, which is like the creme de la creme category, is where you get to actually take over a remote system, take over a box, and own that so you can do whatever you want with it. There's several different kinds of tools we use to this, and these are just a non-exhaustive list. I'm not going to go through them, but they are everything from just an operating system with some tools installed. There's some for cracking passwords. There's some for cracking codes. There's some for dealing with data. One of my favorites is GDB PETA edition. That's a version of the GNU debugger with some added tools to do reverse engineering and do things like buffer overflows and things like that, which I think is really fun. And there's things that we can use to decompile. And one of my favorite tools there as well is called Ghidra. It's this tool from NSA that they decided to release to the public. You can give it away for free, which is pretty generous. And it can decompile native binaries and get not just the assembly code, but it can get actually a pseudo C-like code. So it's really easy to figure out how the program works by using Ghidra. So let's talk about web, because that's this edition. So we're not going to go into buffer overflows and stuff like that today. We're going to give the web a chance. And the web was invented by this guy. You may or may not know him. It's Tim Berners-Lee. And his intention was to create this like shared document system where we can share documents and link to other documents and share information. But it kind of evolved from that. It evolved from having like static content to be dynamic content. And then we started to interact over the web. We started to have chats and have like these message groups and things like that, where we're using it for direct communication. And then we allowed non-technical people to come onto these platforms to create content, like Twitter or YouTube and social media and stuff like that. And it's evolved into the primary global application platform that we serve our applications on. It's anything from navigation on your phone to ordering room service at your hotel. It's all web apps. And if you had asked Tim Berners-Lee or Brandon Ike back in the day if they were ready to produce the next global application platform, they probably would have made some different choices. And this all poses new vulnerabilities, new challenges, because it's a different mode of operation than what we are used to with classical applications. And there are really many types of exploits for the web. There's so many, so this is a non-exhaustive list. We have cross-site scripting, we have SQL injection, template poisoning, prototype pollution, misconfigurations, broken authentication, phishing, spear phishing, third-party vulnerabilities, and so many more. There's actually so many web exploits that some people decided we need an interest group to handle all this. So there was this group called OWASP, stands for the Open Web Application Security Project. It was founded back in 2001, and their main goal is to kind of spread awareness about common vulnerabilities and common threats to web applications. And they released this top 10 list, which is famous for saying what are the top 10 threats that's threatening web applications at the moment. And these are the most critical security risks that are facing web applications at that time. And there's this other project as well, which is called the CVE database, which is lesser known, but it's very, very well known in cybersecurity circles. It's this public repository of known exploits and known vulnerabilities with examples and POCs of how to perform them. Every time a new exploit is found, it's given an identifier, which is CVE, and the year it was discovered, and some kind of sequence number. And they are primarily used for risk assessments to figure out the threat horizons of your applications, to see where your risks are based on the vulnerabilities of your dependencies. But for CTFers, it's an awesome treasure trove of goodies with so many fun stuff that you can pick from there to figure out how to solve the challenges. And there are many CTFs that you can try out. There's some public ones that are online, like Hack the Box, Try Hack Me, and Pico CTF. Google arranges one yearly. They use it kind of in the recruitment process as well. We have this thing called the Juice Shop, which is this Docker image of a web application, which basically have implemented all the OWASP security flaws in one application, so it's the least secure web apps ever written. And then in DMB, we have Hack the Bank that we launched at this conference that you can participate in now. It's going on now. And I'm going to give some examples from that later. And at the big hacker conferences like DEF CON and Black Hat, they have CTFs, and those are just like the Olympics, because that's the one where people send teams from all over the world. And now enough talking. Let's check out some of these challenges and some of these exploits live. So I have to close Teams, because that's not what we're trying to do. Let's see if I can make this happen. No. I have to end the slideshow. Okay, nice. Awesome. So now I'm going to do some things live, so they may or may not work. So this is kind of high risk, but we're going to give it a go anyways. So just by the sound again, how many of you make some kind of web app? Hey, awesome. Great. So let's see if we can find some fun demos. Let me start by going online and going here, and I will get into the Hack the Bank portal. So this is the CTF portal that I made, and you can log in using your Google or Microsoft account, or you can register for one. And here are the flags, and these are the challenges that you have to take. So let's check out some web challenges. I think we have this one, Santa's Bingo. So the challenges are always like this. They have like a text, and sometimes there's a hint. And there's always clues in things like the title or the challenge text or the hint. So let's see what. So Santa decided to give you an early Christmas present. All you have to do is guess a value. Easy, right? So let's go into this page. This looks like a mess, and Santa is having a lightsaber battle with the Grinch. That's fun. So make a guess. This is not a normal bingo. You only need to get one right, and you will get a present. So I guess I will try and guess something. Too bad, didn't make it. So it seems to be using PHP because there's index PHP there. And before I do anything else, let me do some recon and use WhatWeb to see what I'm dealing with, because that will give me some information that I can use to maybe find if there's an exploit. So we can see it's using Apache 2.452, is running Debian, and we have PHP 7.3. So that gives me some ideas of what can be going on. Let me check out some more. So it has this link here that says test ignore. Of course, you should behave good and ignore that. No, we shouldn't. So clicking that, it gives me the source code for the index file. And why does it do that? Well, because it has this if test here that says if test is in the query string, then it will highlight the file. That's the base name of PHP self. So PHP self is everything that's here, and base name will return the file name part of that. So that's right, and we have this regex match that says if config PHP is in that query string, we should say ha ha ha, you didn't say the magic word. So let's test that. So let me try if I can just go to config PHP, because that's evidently a file. That doesn't work. So maybe I can call that in context of index PHP, because then base name will return config. Ha ha ha, you didn't say the magic word. So I evidently hit that corner case. What if I do this and tack on test? That didn't work, because I still hit that thing. So let's analyze this a little bit. So we have this regex match. Let me just take this, because regex is this one thing that I always think that one day I will learn how to do that properly, and I never do, and I always end up Googling it anyways. But let's do regex 101 and let the machine tell me what's going on. So it says it matches config, the characters literally. It matches the dot literally with an escape character. It matches the / literally with an escape character. It matches the star token, and it's greedy, so it takes everything beyond that, and then it asserts that it's the end of the string. So let's see what's going on. So if I say config.php, it will hit that. If I do a /, it will hit it. If I do anything else after, then it won't match the regex. So I need to put something after this in order to get to that thing. So let me try that out. So if I do index PHP, config PHP, and I do slash something, and I do test. Doesn't work. But I get a fail. So it failed to open a file ASDF. So that means the base name now returned this instead of the other one. So I need to figure out how to get base name to return this. So before I do that, let me just go back there. Let me check out what base name does. Check out that function. See if there is anything interesting in the manual about this function. So it says it returns the trailing name component of a path. So basically everything after the last slash. But there's a caution here. Base name is local aware. So for it to see the correct base name with multi-byte character paths, the matching locale must be set using set locale. If a path contains characters which are invalid for the current locale, then the behavior of base name is undefined. An undefined behavior, that's something we can exploit because that means we don't know what will happen. So that's cool. And this means that if there's any characters in the path that it can't decode based on the encoding that's set, then something fun can happen. And I know some things about this setup. It's using Debian Linux, and it's using Apache and PHP 7. So I can create a little test script to test out what happens. Let's see, it's PHP base. Yeah, PHP base. So I have a test script. Come on, type. So it's pretty easy. So all it will do is it will go through everything for up to 0x100, and it will try and evaluate base name plus that character against this string and see what it returns, basically. And in order to replicate the environment, I just created a quick Docker file where I just run the base from the Apache, and I just copy this script over, install the dependencies, and we try. So if I just do docker build -t php test dot, it will build that image for me. I didn't type that correctly. No, built is not build, so like this. And I can do a docker run, and I make it interactive. And I will do php test, and let's just do /bin/bash. So now I have an interactive shell to that box, and the test PHP is the same one. So if I do PHP, test PHP, it will just go through that loop, and lo and behold, we see something interesting here. So whenever the character is something within between 0 and 127, meaning the ASCII characters, it will return that character. But the minute we are over into the extended space of ASCII, well, then it will return config.php, so we trigger that undefined behavior that we read about. So that means if I add a non-ASCII character to the end of this, it should return config.php. So let us test that out. I will do config.php, and I will need slash and some kind of custom character. So let's do ff. And I need the test query string. So that will cause base name to return config.php instead of that special character. And since test is set, it will highlight that for me. So when I do that, I see the contents of config.php. So now I'm exploiting a flaw in PHP to find a file I shouldn't be able to see, which is pretty cool. So that's one, and now I can take that flag. I can go back here and Santa's bingo, and I can just enter that and get my points. So now I solved that because I see the flag. So that's one little exploit. Let's see if we can find some more. Let me exit this. What else to do? Let's do one more PHP since we are in PHP territory. There's in the pwn category, there's one called receipt uploader. Where's that? Receipt. This is cool. So this is an awesome web application where you can upload a receipt. And let's see, I have prepared a couple of things because it's probably somebody takes a picture of a receipt and uploads a picture. So I have this awesome picture of a cat. So I will take that and upload that and see what happens. So it says it's a genuine image PNG, and I can click it, and I find my image. That seems benign enough, right? What happens if I create a PHP file and upload that? Can I run that? That would be beneficial, right? Maybe they haven't thought about this, the designers of this system. So let me upload that and see what happens. No, invalid image file. Upload failed. Try again. So evidently it tries to figure out if this is a real image. So what could I do? Well, images, they are binary, but they have this one place inside for metadata. It's called EXIF data. And it's just this thing to put in things like what's the size, what's the date it was captured, if it was captured by a camera, what type of camera, and stuff like that. And I have this tool called EXIF tool. So that if I give that cat, I will see these metadata. And these are stored in plain text inside the image. But what I could do is I can add some metadata to this thing. So I can say comment equals, and what happens if I give that some, come on, correct keyboard layout. Awesome. If I give that PHP code, so let's do PHP info. See if that will do anything. So now, no file. I have to have space. So now if I check the cat out, I can see that there's a comment section and it has that PHP code. Let's see if that does something. So I will take again, upload this, cat PNG, and let's see what happens. Oh, didn't do anything. But that is because the preprocessor expects the extension to be PHP in order to do PHP processing. So if I just do copy of cat PHP to cat PNG to cat PHP, maybe it doesn't check the extension. So let's see what that does. So now I uploaded that. It still says it's an image, but it checks the magic number at the file header, and that evaluates to a PNG. What happens if I click this? Well, PHP does what PHP does best: screw everything up for you. So you can see the bytes of the image. Then it evaluates PHP info and puts that to the screen. And then at the bottom we get the rest of the image, because PHP goes, I don't know what this is. Hey, PHP, I know PHP. Yes, I'm best. Awesome. So now we know that we can execute code. So now we can manipulate this. So if I do EXIF tool and I do, let's say, comment, and let's set this to something more malicious rather than PHP info. Let's do shell exec and see if I can run ls, for instance. Come on, there it is. And you have to do cat PHP this time. So now I added the code to do the shell exec just to verify it's there. So if I upload this, I should be able to list out some files. So I upload that cat again. You got a new name. And now I can see comment, and here's a file name, here's a file name, here's a file name. So this is all the other people's uploads that was trying to solve this challenge. So evidently I'm a bit far up, so let me go one directory up and see if that helps. So now I'm executing shell commands on a remote system through an image, which is pretty neat. So let's see if I can do that. And here I can see I have comment, flag txt, index PHP, and probably flag txt is what I'm looking for. So I can just change this to a cat and do flag txt. So now I'm going to use the cat to cat the flag. So let's see if we can do that. And there we cat out the flag. Watch a lot of Mr. Robot. And I can take that back and exchange that for points as well. So that is also a fun one of PHP. But let's go deeper. Let's see something else in action. How about we do some cross-site scripting? That's fun. So I'm going to do this, and I'm going to just restart my container just to make sure that it is behaving, because this is kind of unstable because people are attacking it live as we speak, and sometimes, since cross-site scripting is enabled, they break it. But this is also back in the portal. Let's go to flags. I believe this is in the web. So it's called admin jokes. So here we have a link to admin jokes. Let's see if that container has spawned. Then it's done, so that means we can start attacking this thing. So let's do this. So this is a messaging wall, I guess. If I refresh, I can see there's an admin pasting to it, or posting to it. And evidently there are jokes, so what do you call a fake noodle? An impasta? That's great, admin, thank you. So let's see if we can do some cross-site scripting, because I can all seemingly type messages. So I can do that. My name is Wild Shazam today, that's awesome. So let me try the basic cross-site scripting demo you always see, adding a script tag with alert. And that didn't work. So they did a good job. They escaped these characters, so I get the text and not evaluate the script. But have they thought about everything when they made this? How about if I do some sneaky encoding to this script? What will happen then? So if I were to go to URL encoder and URL encode this, will that pass their tests or regex for identifying the script tags? What happens then? And then we have XSS confirmed. And this is usually where all cross-site scripting demos end, because yes, we have a pop-up, and you may ask, why is that dangerous? Well, it's dangerous because this script is evaluated not just by you, but any other who've used this portal. So how can we exploit that? Well, what I would like to do is probably something I need to get from this admin. Maybe I would want to get the admin's session or his password or something like that. So let's see, I have prepared a little JavaScript, because this is what I would like to execute. So I've set up what's called a request bin or a request catcher. So this here, this will get a request if somebody's made, so I can test it out with using curl. So I can use this. So that sends a GET request, and I get a confirmation that, or a POST request, and I get a confirmation that that has happened. So now I want to have the admin post his cookies to my request bin so I can steal his session or figure out some other secrets. So running this fetch thing, where I just send the cookies to that endpoint, would be beneficial. But that's not going to work, because there's this thing called cores, which is these things that make all developers who do web apps crazy, because they only try to figure out what do I need to put in which header to make this work, because where do I put the star to make everything talk to each other. Because what happens now is if I run this code against this page, I will get a course rejection from the browser saying that, no, you can't call this domain from this domain, because that's not allowed by any headers that I've seen. So we need to find a way to circumvent that. And there is a way to do so, because there are many ways to make requests off of web pages. And one such thing is the one I do in trial 2. So if I do trial 2, we can see I take the cookies and I make an image, and I set the source of that image to be my request catcher, and I append the cookie to the query string. And this will be fine, because you're allowed to link to images anywhere, because people use CDNs and stuff like that for images. So images are not blocked by the browser. So if I go here and URL encode this script and post that to the wall, if everything works, hopefully, XSS is confirmed still. And if I go to my request catcher, you can see the admin calls are coming in at the top, and I can read the cookie. So if I take that cookie and I go into, thank you. Take the cookie and I go into URL decode this time, paste it there. I need to do it twice because it's doubly encoded. And there I get my flag, hashtag I eat cookies for breakfast, which is cool. So that's cross-site scripting. So let's check out another fun thing. Do you have time? Yeah, we have a couple of minutes. This is a real fun one. So let's do unserialize. This is no. Let's do unserialize. That's a fun one. So that is this. Let's see if I can find it. Serial. No, it's in pawn. It's in pawn. And when it's in pawn, that means that there's a chance that we can get remote access to this thing. So this is the Grinch serial killer. If I look at the task, it says that we have identified the villains through Santa's blog. And these are the top 10 most wanted characters on the North Pole. And there was 5,941 applicants to this list, so go figure. It seems a bit uncivilized, which is an odd number. Maybe that means something. Let's keep a note of that word and just do some recon. So let's just do a what web to see what we're working with. And we will find out some neat stuff. So it's powered by Express. You can see that here. That means this is a Node.js application. And it hints to something about serialization. It's a serial killer. It's uncivilized. So maybe Node has some kind of vulnerability when it comes to serialization. So let's check that out. There's also this number. So let me just take that number. And I will Google that number and Node.js and see what I find. And here we can see that there is a CVE attached to that number. That's the Common Vulnerabilities and Exploit database. So if I go into that database and see, it says that an issue was discovered in the Node serialize package for Node.js. Untrusted data passed into the unserialized function can be exploited to achieve arbitrary code execution. That's fun. Why does that happen? Let me check out that package. So Node serialize. Let me check out the package. And we can see that, okay, what is this thing? Why didn't you get a, why is there no readme? Is the wrong package? No? Okay, let's go to the GitHub then. So this serialize an object including its function into JSON. So not only can you serialize data like name Bob, but you can also serialize behavior like this function. And that is, probably somebody thought that was a good idea, but JavaScript has a couple of quirks. One of those quirks is what's known as an immediately invoked function expression. If you don't know what that is, it's this thing. So I can define a function that is anonymous, and it has a body where it does, let's say just does console log. If I was a YouTuber, this is where I would probably go, please subscribe. But I am not a YouTuber, but I'm going to do it anyway. And let's do return 0. And that's that. And if I close that paren, and I do this to invoke that function, what happens is that function will get invoked immediately, and the result is then returned as a value. So it says please sub and returns 0. So if I serialize that function, the minute that is unserialized or deserialized, well, then that function is invoked. So I can send a function that will be run by the server. That's fun. But let's figure out where I can do this, because there are no inputs. So let me check out the network tab and see what's going on, if there's any fun stuff I can exploit there. So I can see there's no most wanted, and I get this package. This is a cookie. And let me see if I can do anything with that. It's HTTP only, so I can't steal it or anything. But that's base 64 decodes. Let's decode that thing. So, lo and behold, that's a JSON object. What do you think the chances are that this is deserialized on the server side before it's evaluated when it gets back? Let's test it out. Let's see if I can change the name. I'll change it to Espen for fun. And I would take this, and we will go to encode. Now we just encode it. And come on, encode that for me, please. And I'll take this, because what happens is that if I change this cookie, when I do my next request, it's sent back to the server. So let's see what happens now. So I take this, and I can now see that I'm logged in as Espen. So that means that that was evaluated server-side. Fun. That means I can craft my exploit. So the exploit is pretty simple. Let me just carry it out. So it uses... it's just this normal JSON, and it uses this prefix for the function to let that serialized library know that this is a function. And here I have this anonymous function as an immediately invoked one, and you can see that it does response a shell, and it calls that through a socket through this to this port. And it's immediately invoked, so it's invoked the minute it hits the server. So in order for this to work, I need to have a terminal that's available, that's listening on that port, that will get the callback, and that way I can set up my reverse shell. So here I have a machine in Azure that's called Arne. And what I will do is I will set up Netcat to listen on this port. And I will take my little exploit, which is just spawns a child process and runs bin bash, and then it pipes that to this socket. So if I do that here, adds that, do encode, and I can take this whole thing, paste that in here, and let me just make this smaller so you can see the terminal as well, so you can see the connection coming back. So what I'll do now is I will update that, and I will refresh this page. And that didn't work because it rewrote my cookie. So let me just do it once again. And the minute I run this now you can see down here, it called back. And I'm suddenly not at Arne anymore. I'm at Node Sandbox. That means that I now have an open shell to the server running that. So this is the index. That is where that is the source code for the server. So here you can see that. And if I do list out the root directory, that's usually where the flag is, and there it is. So I can just cat out flag.txt, and that's my secret. So that's how I exploited a known vulnerability in a third-party library, where somebody thought it was a good idea to be able to serialize functions. So that's the last demo I think we have time for. So let me just do this last slide with the takeaways for you all. So let's start from current slide. So the whole point of this thing was to show you that exploits are fun and they are good to do. And CTFs are really fun and educational, and they can really enrich your teams and the way you build your applications. Because building these offensive skills, that kind of changes how you view security, and it will make your systems more secure. And I want you all to go home, be curious, and fuss all your inputs, and play with your applications and try to break them. Because that is, if you discover something, well, that's something you won't have to worry about in the future. So put on your hoodies and go out and hack, 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 because it's so much fun. Thank you so much. Any questions? We have like 1 minute. Yeah, I can't see, so.
I used to use T-search back in the day for memory manipulation.
Yeah.
Is there anything you would use today that's an equivalent?
For memory manipulation, I'm old school. I use GNU debugger, and I just fuss the inputs and view all the registers and memory addresses to see what happens. But there's pawn tools, which is this Python library that kind of makes it even more easy, because there's like these pattern generators and searchers that can like find all the offsets in memory for you, and you can search for which, it has this database like libc to find which version of libc you're linked against and stuff like that. So you can find all the ROP gadgets and fun stuff like that. Yeah, My other talk, that's called Just How Hacking Works. There we go into roping and memory manipulation and buffer overflows and that stuff as well. So check that out if you have a chance. Any other questions?
Yes. When do you know to stop?
Huh? When you know to stop?
Yeah, because if you're gonna do some penetration hacking,
Yeah.
you might be going over breaking the law.
Yeah, you should never break the law. You should do what you have permission to do. And that's why CTFs are cool, because you have permission to break them. They're there for you to break so you learn. So it's safe. Yeah?
But where do you find legitimate CTF sites?
Where do you find?
Legitimate CTF sites?
It's really hard to hear you. Can somebody relay?
He's asking where do you find legitimate CTF sites? So like
Yeah, so-
CTF you mentioned earlier.
Yeah, so Google CTF is one, and there's the Hack the Box, Try Hack Me, Pico CTFs. These are these platforms which have like continuous CTF challenges posted to them all the time. We have a Hack the Bank going at NDC now that you can join. You just go to our stand and you will find how to join. So yeah, and there's also the Juice Shop. That's this Docker image that you can pull down. It's pretty awesome, pretty fun, and the kind of entry level, but it's fun. Well, then that's all, folks.